Okay, so moving on with data transformations. Here we have the first one. One way of transforming data is normalization. One good example for normalization would be our Z scores that we have for our A levels. So we make the Z scores by normalizing. It's actually standardized scores. So we take the entire set of data and we scale it to fit between 0 and 1. So that's normalizing, or -1 to 0. So when it comes to standardizing, it's also a similar process where we take the entire data set and we reduce the range of it by using standardization techniques. So that's how we can transform data. And another way of transforming data is where we select a set of attributes and transforming it. Say, for example, if we take, sorry, sorry for the interruption. So when it comes to attribute selection, it's mainly about constructing new attributes from the set of given attributes. So we can even maybe take two columns that are related and maybe construct a new column using that. So let it be like, say, the number of family members and house size, but that's not a really good example. So let's go with the second one, which is discretization. So this is where we replace the raw values of numeric attributes by interval levels or conceptual levels. So say if we take the income level of a household per month, it can vary, right? So we can have intervals where we group them and make sure it's income levels, which is like high, medium, and low. So we would be going ahead with the analysis by using a categorical variable, high, medium, low, and not really a number, because the numbers can be everywhere when it comes to the monthly income of a household. So the third one is concept hierarchy generation. So say that is something similar to grouping. If we have the attribute city, we can get the cities in one particular country and put the country name instead of the city name. So we can get a country level analysis. So that's another way of transforming data. So this section is about data reduction. While working with huge volumes of data, it's really hard. So when it comes to, for example, cancer data, genomic data, we can see the number of variables to analyze is quite high. So we have to go ahead with data reduction techniques in order to get a data set which is easy for us to process and for the tools to process. So the first way of data reduction is attribute subset selections. So that would be taking off the variables that doesn't really give us a proper p-value or a significance. For example, I'll go back to my this one. So when it comes to this data set, we can see that pets and the emergency contact doesn't give any value to the data set. So might as well get rid of it. So like that, we can go through the data set, and that's one way of deciding how we can select the attributes. And another way is we can use the level of significance and p-value of the attribute for the predicting label to decide whether we need the variable or not. And the other one would be dimensionality reduction. So that is where we have principal component analysis and wavelet transformations coming into play. So these can be big names, but you can Google it and get to know later because I'm covering only a part of it. So when it comes to reducing the dimension, so as you can see in this small video that's playing on my right side, it's a 2D data set, right? It's a 2D data set where we can fit a regression line. And when we convert it, when we convert the line, we can get it to be a 1D data. So that's about reducing the dimension.